Uh, in fact, there is some context in chapter 2. After the chain rule, we have a section called implicit differentiation. That is what we have learned last week. But that section we didn't finish. But I don't bring chapter 2 parts. So today we will learn chapter 3. Applications of differentiation. Chapter 3. Applications of differentiation. In this chapter, you will see how we use the theory of differentiation to find the maximum, minimum, or relative maximum, relative minimum of a function. Then we can give the whole behavior and the graph of the function. We can sketch the relative, somewhat precise graph of the function. So, chapter 3, applications of differentiation. The first section of this chapter entitled maximum and minimum values. Okay, first we give the definition of maximum or minimum values of function on some set or in this domain. Okay, let's see be a number in the domain D. D is the domain of the function f. Okay, so f is a function from some subset of real number system to real number, the set of all real numbers. Suppose D is a subset, for example, a closed interval maybe. And the range of f. Range of f means the set of all possible values of this function f on D. Graphically, if we take a look at the graph of the function, maybe this is a closed interval A, and the set of all possible values of this function from the set D. So the smallest number in this range is lowercase m, and the largest, greatest one is capital M. Then m is the largest one of all possible values. Then we call m the absolute maximum value of the function f on its domain D. Okay. We emphasize C is a number in D. C is a number in D. Suppose, C is a number in D means f of C is exactly a value of the function. Okay. At some number in D. And this number is the largest, the greatest of all values, possible values of the function at numbers in this set D. So we call this number, or the value of f at C, is the absolute maximum. Absolute maximum value of the function f. Okay. Likewise, in this case, lowercase is the smallest one. Then this one is the absolute minimum value of the function f on D. This is the definition of maximum, absolute maximum or absolute minimum. Sometimes we omit absolute, this adjective, absolute, just call maximum value or minimum value. So similarly, we can define absolute minimum by replace this relation f of c is greater than or equal to f of x by f of c is less than or equal to f of x. Here, c already given. The function f is already given. The x, of course, we have to indicate the values of x. X means for all x in D. All x in D. Okay. All x in D. This is the absolute maximum and the absolute minimum, the definition. Okay, some textbook called absolute maximum global maximum, and the absolute minimum global minimum, or briefly maximum minimum. Okay, maximum and minimum together are called extremum. So we have another terminology. Okay, in Mandarin, maximum 我们叫做极大值或最大值 ，minimum 极小值或者最小值 ，extreme values 就是极值或者最值啊，是这样子。所以讲一个函数的最大值、最小值，其实是指的绝对最大或绝对最小，或 global 或整体最大、整体最小，简称为最大值跟最小值。意思就是在某个集合上，所有可能的函数值最大的那个、最小的那个。Okay, this is a requirement from this campus, this university. Even in this class, I have to sometimes use some Mandarin because not every student understand every sentence from the teacher. Okay. So, global or absolute maximum, minimum, or extreme values. Relative to global or absolute maximum and minimum, we have another concept for maximum and minimum called relative maximum, relative minimum value, or local maximum or local minimum. So in contrast to absolute, we have relative. So for example, for this number, for example D, for this number, though the number f of D is not the minimum of this function in D or on D, but fd, in fact, this number is the minimum of the function on some neighborhood of D, some, only some, if you can find, not too large, for example here. Okay, by a neighborhood of D, we need an open interval containing this number D. This is a neighborhood of D. So on this neighborhood, exactly, this one is the minimum, okay, on this open interval. So we call FD a local minimum or local minimum value of this function. Similarly, for this number C, though this number is global or absolute maximum, but for this number, this number is the greatest, the maximum of this function on some neighborhood of C. In fact, this neighborhood may be pretty large, but we can consider local means we don't need to consider the large radius. Maybe a small radius is enough. But for this number A, not a relative minimum, because any neighborhood of A, there is always a part not contained in its domain. So when we talk about local or relative minimum, relative maximum, we always consider the interior point of its domain or the set under consideration. Okay. So, besides absolute or global maximum and minimum values, here is another concept of maximum and minimum called local. Local maximum or local minimum values of this function. Same, a local maximum or minimum value, local maximum value and the local minimum values are called local extreme values. Same. Local extreme values, we add an adjective local in front of the extreme this word. 好的，除了最大值跟最小值之外，我们也有讨论局部最大跟局部最小，或叫相对最大、相对最小。讲到相对最大、相对最小呢，我们永远是考虑一个实数